In the Beginning by Dr. Walt Brown. We will be taking a look at the flood phase. Yeah, the flood phase. That's going to be on page 138 of In the Beginning, where you can get that at hpt.rsr.org. Oops. Pilot error there. Forgive me, please. The flood phase. Each side, the flood phase. Each side of the rupture was initially a 60-mile cliff. In the bottom 90% of the cliff face, compressive vibrating loads greatly exceeded the rock's crushing strength, so the bottom 90% continually crumbled, collapsed, and spilled out into the jetting fountains that removed support for the top 10% of the cliff, so it also fragmented and fell into the pulverizing hypersonic flow. The 46,000 mile long rupture rapidly widened, reaching an average width of about 1,400 miles all around the Earth. Let's see what it says here. Figure 62, flood phase. Sediments in the escaping water increased until their volume nearly equaled the volume of water gushing out. These suspended particles quickly settled and buried plants and animals in a chaotic mixture. During this phase, a phenomena called liquefaction sorted sediments, animals, and plants into uniform horizontal layers that covered vast areas. Traces of these dead organisms are called fossils. Global liquefaction is explained on pages 205 to 223. Okay, moving on. Later in the chapter, The Origin of Earth's Radioactivity on page 387 to 441, you will see that the water in the sponge-like pockets in the crust experienced tremendous heating and expansion that forced that water back into the chambers. Therefore, the hydroplates settled slowly. Sediments swept up in the escaping floodwaters gave the water a thick, muddy consistency. These sediments rapidly settled out over the Earth's surface, burying many plants and animals, forming the fossil record. The downward sagging edges of the massive hydroplates slowly closed the powerful jetting fountains, but massive amounts of water continued to leak out. Because today's major mountains had not yet formed, global flooding covered Earth's relatively smooth topography. As explained on page 136, salt had precipitated out of the supercritical subterranean water before the flood began, covering the chamber floor with solid but mushy salt. Escaping water swept much of it out of the chamber. When sediments falling through the floodwaters blanketed the pasty, low-density salt, an unstable arrangement arose, much like, let's see the next page. Much like having a layer of light oil beneath a denser layer of water, a slight jiggle of the mixture will cause the lighter layer below to flow up as a plume through the denser layer above. A plume of salt is called a salt dome. Deep salt layers, some 20,000 feet below today's sea level, are resting on what was the much deeper chamber floor. Wherever the floor roof was blown off, the floor below rose. Whenever the chamber roof was blown off, the floor below rose. Two such places are now the Gulf of Mexico and the Mediterranean Sea. The supercritical water in the subterranean chamber had also dissolved minerals containing calcium, carbon, and oxygen. They too had precipitated out of the supercritical water as temperatures rose before the flood, blanketing the chamber floor with limestone particles, calcium carbonate, I believe, particles as the flood waters escaped. These particles were swept up and up. As the flood waters escaped, these particles were swept out and up onto the Earth's surface. The total volume of limestone on Earth today is staggering, and it cannot be explained by processes occurring at the Earth's surface. See the origin of limestone, pages 267 to 273. Today, on the floor of the Gulf of Mexico, supercritical water sometimes escapes through salt domes and precipitates asphalt, tar, the least volatile component of petroleum. What is the hydrocarbon source? Obviously, organic material. Recall that black smokers, with their escaping supercritical water, are usually surrounded by buried vegetation and large ecosystems, such as swarms of giant tube worms feeding on chemicals dissolved in supercritical water. That organic material is quickly dissolved by the supercritical water when the vents shift locations. As the supercritical water jets up into the cold seawater and cools, hydrocarbons quickly precipitate, paving the seafloor with a tar residue. Flooding uprooted most of Earth's abundant vegetation and transported it to regions where it accumulated in great masses. Pages 205 to 223 explain how this vegetation was collected and sorted into thin layers within the sediments. Later, at the end of the continental drift phase, buried layers of vegetation were rapidly compressed and heated, precisely the conditions that laboratory experiments have shown will form coal and oil. The flood phase ended with continents near the positions shown in figure 56 and at the top frame of figure 69.